Okay, so welcome guys in second session of today. Then today now we will do some hands-on. So first we have taken this particular credit of this particular notebook goes to Kaggle and kaggle.com, and with due credits I have taken it from this particular link which is being shown on the. I show this link on the. So from this link I have taken this particular notebook and modified it for our tutorial today. So I'll share this link with you. So now I straightway go to the notebook. So and we are all kind of well versed with Python. So I'll not get into much of Python code, because you guys are supposed to know Python code by this time. And okay, so this is my. I'll close all the unnecessary files so that it is not a distraction. Sorry for that, wasting your time. Okay, so now we are very much through here. You can see. I can see. Can you see the code? Can you see the code? Very clearly seen, right? And my voice is also audible, right? So, like as usual, NumPy imported, Pandas imported, and this time we have some NLP specific libraries, feature extraction, linear model, model selection, linear model, and pre-processing. These are no, model selection and linear model are very much familiar machine learning model itself. And I think pre-processing will use it further down the line, and feature extraction also NLP specific, which you use down the line. So it is already divided into train and test CSV. So we read the CSV files, we see the head now. So here understand what the data is. So here the data set is very simple. Here ID, keyword and location. So location and keyword we are not bothered. These two particular columns we are not bothered. Just we are bothered about the text column and the target column. So target column is nothing but our y variable, dependent variable. And text column is nothing but what we need to analyze. So what we need to do here in this problem is this particular text is given like our deeds are the reasons of earthquake. It is true. Then forest fire near La Ronge, Sask, Canada. It is also true. So these kind of things are given. 1300 people receive wildfires evacuation. So this is a tweet again. So this is also true. So like we have a lot of some related to wildfire and nature. There are some tweets given on a particular topic, and then the tweets are classified into true and false. So basically 0 and 1. So we have a lot of training data given. So for you, I have this head is displayed, first 5 rows. So first 5 rows we can see that keyword and location are all null columns only, NaN number only. But then I have randomly chosen five particular. You want me to choose 10? I can choose the 10 words. Like I have chosen randomly now. Randomly I have chosen 10 records from this particular data set training file. So you can see that keywords and location are not null for all the cases. So they are given, but we are not much concerned with keyword and location. We are concerned with the text which is taken as X and target which is taken as Y. So see, target is 01010101. So first we'll use with this 01 label and text, we'll train our data, and then of course we can use this for prediction. So similarly, like test data also displayed similar data. So then what next done is, what we have done is that look at the data first, the example which is first tweet we are looking at it. So like first it looks like I love fruits. Then like same thing looked in train data, second record. So this is forest fire near Ronsang, Canada. So just for example. Then we are building vectors now. So I'm first giving you an example. Like, see, suppose our example text is, it has nothing to take with this particular problem statement. I'm just giving you an example. So here, example text is John is a good boy. John watches basketball. So now with a very simple scheme, I am converting into a vector. So what I am doing? I am importing something called from feature extraction. I am importing something called count vectorization. So this will be a very familiar piece of code with you as you go down the line NLP as you progress with NLP, this count vectorizer will be very familiar piece of code. So see the sentence. John is a good boy. Full stop. John watches basketball. So this is a sentence. Then what I have done, count vectorizer, I have made an object. So with count vectorizer object, I just done a fit. Fit on what? Fit on example text. Example text. I have done a fit. Okay. So this fit, when I print it, vocabulary, if I print the vocabulary, so what it has done is, see, it has broken down into vocabulary. So it has ordered into ascending order of ABCD, okay, ascending order of alphabets, it will order. So B, basketball is taken as 0, then G is taken as 2, I is taken as 3, then 4 is John, and 5 is watch. So watch is, W comes in the last, so it has gone in the watch. So it has created vocabulary. This vocabulary I have shown here. Now I want to convert it into a vector. So you note that how many are repeated 2 times here. John is a good boy. John. So John is repeated twice. Okay. John is repeated twice. And you note that John is there on the 4th position, means 5th position. 0 to 4 means it is the 5th position. So on 5th position John is coming. So when I do a transform on example text, so first I got the vocabulary. When I did a fit, I got a vocabulary. When I do a transform, I got a vector. So see how the vector is. So vector is 5th position. First, 2, 3, 4, 5. So 5th position John is there. Means 4 index John is there. So it has become 2. So we have converted this particular sentence. This particular sentence I have converted into vector. A very simple vector. How it has been done? Just count the occurrence. So John is coming twice. That's why it is 2 here in the 4th position. Rest all words are occurring only once. So 1, 1, 1, 1. So we have converted into a vector. It is a very crude form of vectorization, but it still works. Let us see example 2. Again count vectorizer imported. Now my text is this one. The quick brown fox, which I have highlighted here. The quick brown fox jumps the lazy dog. The quick brown fox jumps the lazy dog. So this is my particular text. Then I have done same fit transform. Now you see here. So what is repeated twice? Quick brown fox jumps the lazy dog. See D is repeated twice. D is repeated twice here, right? So see the vector. See the vocabulary first. D is there. D is there. Which position? D is there in the 6th position. Last position D is there. In the alphabetically it is coming in the last. So Q R S T. So T it is 6th. So on 6th position we see 2. Rest all are 1. Okay. So see D is basically a stop word. But right now for the simplicity we have not removed the stop word. In some other next class and all, we'll see how to remove stop word. See here also. While creating the vocabulary, John is a good boy, right? So this particular A is not there in the vocabulary. You see vocabulary, is there. Is also is a stop word. But is there, but A is not there. So it has automatically removed A actually because it knows that A doesn't have any value. But still it has kept is. So we have to specifically process it and remove is from here. So here also if you see, our count vectorizer should remove the D is not removed. D is not removed. So these counted as so it has come in the vector. So this is how, this is what is the problem. Rest all is machine learning. So now count vectorizer, we have just seen that first we are looking at 0 to 5, 6 rows, 0 to 5 first records. Example just it is displayed. Same thing which I have explained you above. So now what we have done, train vector same we have taken fit transform from that count vectorizer fit transform. We have taken the complete train data set. And where we have converted here. So text was what? Text was, let me search for text and show you what text is. So text is see this text is nothing but a particular column of our both train and test. We have text column, so it is a column. So that column they have taken here, and the column they have taken here. See the column. See here, train df is our train data, text is we are taking its column, and full we are converting into count vectorizer. So similarly we have done for the test. And you now know that how count vectorizer works, right? So till now, any questions here, Soman? Anybody? Very simple, na? So very simple. Now we have here they have created so simply converted into vector, and now what we are doing, a Ritz classifier is a machine learning. We are importing Ritz classifier, then we are importing cross validation score, and then we are processing train vectors which we had converted, train data, train vectors, train data target train vectors is nothing but your x variable. Here we have given y variable, and CV fold we have taken 3, and scoring we are doing on FN score. So this, I think this all code should be familiar with you by now, because we have many times we have done in our machine learning classes. So we see that there are 3 models. Accuracy is around 59% accuracy here, 56% accuracy here, and 64%. So there are 3 accuracies. We had taken 3 CV equal to 3. So CV equal to 3 means we had divided data set into 3 sets. So 3 times we have run machine learning. So one set we got 59% accuracy, one set we got 56, and one set we got 64% accuracy. Okay. So after that you can do that you can do predictions like here, yeah. So same you can do predictions. So now here you can see the text which is original text which target came, and here is the predicted data. So you can see the comparison. Same thing now over. The problem is over. So the heart of the problem is count vectorizer, and now you know how it works. So that's what is this whole coding. Rest all is simple coding. And Sahuji, for you like this thing will be a new thing, because you were not there in machine learning class. So this will be something new for you, like what is the meaning of CLF, what is the meaning of train vector, like how it works, like CV equal to 3, what is F1. So these things will be new for us, but if you want to learn them, I'll request someone to take a 15-20 minute class for you, and he will explain you all these things. But remember, these are very routine things in machine learning. But still, I will arrange a class for you for 15-20 minutes. He will explain you. Someone will explain you all these things. Okay, Sauji. Hello. So I think we are done with the problem. Any challenge in this problem? So we are simply using count vectorizer and converting our text into vector just by counting it. If it is coming 2 times, then that will replace that particular word John with 2. Like that we are doing. So it's a very simple schema, very trivial schema, and here we are getting accuracy of 60%. So naturally it is not good. But if you want to improve the accuracy, you can use little more advanced, like he has given, like TF-IDF, LSA, or this LSTM, RNN. If you use any of these particular advanced algorithms, then you may get better accuracy. But right now that was not our aim. Our aim was just to see how words are converted into vectors before putting in machine learning model. So any model you can use. You can use LSTM, you can use. So these things you can use to improve the accuracy. So this is your first example. I'll share the PPT with you, and that's all for the class today. And thank you so much. Any questions, please let me know. I'll take a break for 2 minutes. Sauji, are you there? Chalo, so anyway. So this is your first NLP tutorial. NLP is not very tough. Just convert your words tokens into vectors. That's all you want. After that, everything is machine learning. So converting word into tokens into vectors, there are different schemes, simple to complex. So this is one of the very simple scheme we have seen. Just count it and replace that word by its count. So what will the count represent? Count will represent the importance of that particular word. See here in this word John. So John is coming 2 times, right? So where was the John? See, John is coming is 2 times. John is coming 2 times. That means John is important here. Why John is important? Because the sentence is about John. You read, it is all about John. John is a good boy, and John watches basketball. So John is the hero for this particular document, right? So if it is coming more times, then we know that this John word is important for sentence. So similarly, they are assuming that if any word is coming more times, count is more, it is more important to that particular analysis. So that is basic assumption here, but which is not true always. So I think we stop here. Soman, any doubt in this? It's very clear. I think it's very simple, damn simple. Just count vectorizer you have to improve, and you have to pass the text in that. It automatically converts into vector. ठीक है ना? So we'll take more complex examples as we go forward. Okay. So thank you so much. I stop recording here.